Hey there, science fans! Have you ever heard of solar flares? These are intense bursts of energy from the sun. Imagine a giant explosion on the sun's surface, releasing a tremendous amount of light and heat. That's a solar flare. These flares are not just visually impressive, they pack a punch too. Solar flares release a barrage of radiation and charged particles into space. Some of this energy can reach Earth, causing all sorts of interesting effects. Solar flares remind us that the sun, while essential for life, is also a dynamic and powerful star. Understanding them helps us prepare for their potential impacts on our planet. Now let's delve deeper into how these solar storms originate. So what causes these solar fireworks? The answer lies in the sun's magnetic field. You see, the sun is like a giant ball of moving electrically charged gas called plasma. This movement creates a powerful magnetic field around the sun. Sometimes these magnetic field lines get tangled and twisted like a knotted rope. When the tension becomes too much, they snap and reconnect, releasing a tremendous amount of energy in the process. This energy release is what we observe as a solar flare. Think of it like suddenly releasing a tightly wound spring. The energy has to go somewhere, and in the case of a solar flare, it explodes outwards into space. Now, when a solar flare erupts, it sends a wave of radiation and charged particles hurtling through space. Some of this energy can reach Earth, interacting with our planet's magnetic field and atmosphere. One of the most noticeable effects is the aurora borealis, or northern lights. These colorful displays in the sky are caused by charged particles from the solar flare interacting with gases in our atmosphere. However, solar flares can also have less desirable effects. They can disrupt radio communications, interfere with GPS signals, and even damage satellites. In extreme cases, they can cause power outages on the ground. So how do we prepare for these solar storms? Well, scientists are constantly monitoring the sun for any signs of trouble. They use specialized telescopes and spacecraft to track solar activity and predict when a flare might occur. It's like keeping an eye on the weather, but instead of rain or snow, we're watching for bursts of solar energy. By understanding the sun's behavior, we can issue warnings and take steps to protect our technology from the effects of solar flares. While we can't stop solar flares from happening, we can certainly try to be prepared for them. Remember, knowledge is power, and the more we learn about the sun, the better equipped we'll be to handle whatever it throws our way.